So, hello everyone, good day. Welcome to our video reporting. By the way, I am Mark Jason Nadisma, the first reporter of Group 6, and the topic we are going to discuss is all about the Chapter 6, Risk and Investment Appraisal. So, objectives. In this chapter, we shall deal with the following: the importance of risk and of its formal consideration in the decision-making process, the use of sensitivity analysis to try to assess the riskiness of a particular project, the use of statistical probabilities to try to assess risk, expected value and its deficiencies in the treatment of risk, systematic and specific risk, utility theory, risk aversion, and evidence on dealing with risk in practice. In this chapter, it is composed of 10 topics. Now we will first tackle the topic 1, which is the introduction. So, until this point in the book, we have all but ignored questions of risk. We are now going to start to confront the issue, and though this is the only chapter with the word risk in its title. So, despite this awkward environment, decisions must still be made. Delaying decisions until the mist of doubt lifts will not be a very fruitful approach since it will never leave. So, what is risk? The risk and uncertainty. Risk is seen as the phenomenon that arises from circumstances where we are able to identify the possible outcomes and even their likelihood of occurrence without being sure which will actually occur. So risk is a possible negatively impact to your financial welfare. For example, the financial losses, your investment value might rise or fall because of the market condition. So when you invest, you have to consider also what possible outcomes happen. So that's why you have to make decisions or choices on what to do with your financial assets. So, uncertainty. It describes the position where we simply are not able to identify all, or perhaps not even any of the possible outcomes, and we are still less able to assess their likelihood of occurrence. So, probably most business decisions are characterized by uncertainty to some extent. Uncertainty also represents a particularly difficult area. So in the next slide, the importance of taking account of risk. So it is important to take our account of risk to consider some ways in which risk in investment decision can be dealt with. So this should be done in the most formal possible way, not as an afterthought. The level of risk fundamentally affects the decision. So we should view very differently the opportunity to wager on a throw of a die and to wager on the spin of a coin. So now let's tackle the chapter 6, topic 2, the sensitivity analysis. So what is sensitivity analysis? So it is to assess the decision on the basis of the base estimate, that is the what the decision maker believes to be the most accurate prediction of each of the input factors. So ang sensitivity analysis dia is kanang financial model that determines how target variables are affected based on changes in other variables. It is known as input variables. So example 6.1, the Green PLC has the opportunity to invest in plant for the manufacture of a new product, the demand for which is estimated to be 5,000 units a year for 5 years. The following data relate to the decision. The machine is estimated to cost £50,000 payable immediately and to have no residual value. The selling price per unit is planned to be £10. Labor and material costs are estimated to be £4 and £3 per unit respectively. Overhead costs are not expected to be affected by the decision. The cost of capital for such a project is estimated to be 10% PE. The project is not expected to require any additional working capital. In the interest of simplicity, taxation will be ignored. Assume also, in the interest of simplicity, that all cash flows occur at year ends. So assess the project using the NPV on the basis of the above estimates. Carry a sensitivity analysis of the above estimates. So, solution. The annual cash flows will be 5,000 times pounds open bracket 10 minus open parenthesis 4 plus 3 close parenthesis close bracket is equal to £15,000 each year. So thus the project cash flows are estimated to be £15,000 per year. So the annuity factor for 5 years at 10% is 3.791. It is seen in the appendix 2. The NPV is therefore negative £50,000 plus open parenthesis £15,000 times 3.791 close parenthesis is equal to positive £6,865. So, thus, on the basis of the estimates, the project is favorable. It has a positive NPV, and that should be undertaken. The estimates are not certain, however, so we shall now go on to look at each of the input factors one by one, to see how sensitive the decision is to each of them. That is to see by how much each factor could vary from the original estimate before the project could become unfavorable or negative in PB, which, while we consider each factor, we shall assume that the factors will all be as originally estimated. So the project in PB is given by negative £50,000 plus open braces £5,000 times close open brackets 10 minus open parenthesis 4 plus 3 close parenthesis close bracket times 3.791 close braces is equal to positive 6,865. To carry out the sensitivity analysis, just one of the factors on the left-hand side of this equation needs to be altered to a value that will make the NPV equal to 0. After this has been done with the first factor, the process goes onto the next one, restoring the first one to its original value and so on. So the first is the initial investment. Starting with the initial investment, putting the symbol I into the equation instead of £50,000 and setting the right hand side of the equation to 0 gives. So that's why the equation is negative I plus open open braces 5,000 times open bracket 10 minus open parenthesis 4 plus 3 close parenthesis close brackets times 3.791 close braces is equal to 0. So to get the I, just first add the 4 plus 3, then subtract it. The answer is 7, then subtract it to 10. So the answer is 3. 5,000 times 3, 15,000 times 3.791, which is the answer is 56,865 pounds. Then 50,000, negative 50,000 plus, sorry, that's why the I is 56,865 pounds. Thus, the initial investment could increase by 6,865 pounds before the project would become marginal. In other words, the actual cost of the machine could rise to 56,865 pounds from 50,000 pounds before the project would become unattractive on the basis of its NPV. So number two, the annual sales volume. So B is the annual sales volume symbol. So the equation B equals 50,000 over open parenthesis 10 minus 7 close parenthesis times 3.791 is equal to 4,396 units. Number 3, sales revenue or unit. The S is the sales revenue unit symbol. So S equals 7 plus 50,000 over 5,000 times 3.799. So that's why the answer is 9.64. To get the answer, just multiply the 5,000 times 3.791, then divide it to 5,000. Then the answer of that would be add to 7. So that's why 9.74 pounds is the answer. So number 4, labor cost or unit. The L is the labor cost per unit symbol. Same as the sales revenue per unit on how to solve. But the difference is you need to subtract, not to add. So that's why the answer is 4.36 pounds. So let's proceed to number 5, material cost per unit. The M is the material cost symbol. So M equals 6 minus open parenthesis 5,000 times 3.79, 3.791 close parenthesis divided by 50,000. So 50,000 over, so is equal to 3.76 pounds. So just first multiply the 5,000 times 3.791, then divide it. The answer will be divided into 50,000, then subtract it to 6. That's why the answer is 3.36. So number 6, cost of capital. A is the annuity factor. Annuity is equal to 5,000 divided by 5,000 over open parenthesis 5,000 times 3 close parenthesis is equal to 3.333. So the value of 3.333 lies on 0.019 below the 50% value. So the discount rate applying to 3.333 is about 15%. That is about 15.24%. Number 7, life of the project. Of course, the same 3.333 annuity value must be used to deduce the life of the project, this time assuming that the discount rate remains at 10%, the original estimate. The 10% column in the annuity table shows that 3.333 falls between the 4-year figure and the 5-year one, 3.791. This means that an extra year causes the annuity factor to increase by 0.621 from 3.170 to 3.9791. The value of 3.333 lies on 3.163 above the 4-year figure. So the period applying to 3.333 is about 4. That is about 4.26 years. So the result can now be tabulated as follows in the table. It comes of the factor original estimate value to give 0 in PB, the difference as percentage of original estimate for the particular factor or percent. From this it can be seen at a glance how sensitive the NPV, calculated on the basis of the original estimates, is to change in the variables in the decision. If, on the other hand, they felt that all the factors seemed safe but that they were doubtful about, say, labor costs, the fact that only a 9% rise would cause the project to become unfavorable might reduce their confidence in the investment. So the practical use of sensitivity analysis. Sensitivity analysis is a type of break-even analysis in which, in respect of each factor, we can assess the break-even point and the margin of safety. Scenario building. The essentials of the project being assessed are put onto a computer spreadsheet. Decision maker can fairly effortless take the analysis a lot farther than we have just done. So the problems of using sensitivity analysis. Despite its benefits to the decision maker, sensitivity analysis has its weaknesses. So sensitivity analysis that does not provide us with any rule as to how to interpret the result. We could carry out more research and possibly reinforce our confidence in the original estimates, but often the doubt can never be completely removed. So now, let's proceed to the chapter 6, topic 3, the uses of probabilities. So there are two types of the probabilities. The following is the objective probabilities and the subjective probabilities. So the objective, these are based on past experience of the outcomes and their likelihood of occurrence. For example, if we know that what the annual demand for a particular product has been over the years, we could assume that this would define the possible outcomes and their probabilities for next year. So for the subjective probabilities, these are based on opinions, preferably of experts on the possibilities and on their probability of occurrence. So example 6.2. Using the data from the example 6.1, let us assume that the factors are known with certainly impossible in real life, except sales value. So extensive market research suggests that annual demand will be 4,000 units or 0.2 probable, 4,500 units or 0.5 probable, 5,000 units or 0.3 probable. So what are the possible outcomes in terms of NPV and how probable is each one? So, solution. NPV at 4,000 units pay is equal to negative 50,000 plus open bracket 4,000 times open parenthesis 10 minus 7 close parenthesis times 3.791 close bracket. So it is equal to negative 4,508 pounds. So the probability is 0.2. The NPV is for the 4,500 units is negative 50,000 equal. So for the 4,500 units, negative 50,000 plus open bracket 4,500 times open parenthesis 10 minus 7 close parenthesis times 3.791 close bracket is equal to positive 1,179. So the probability is 0.5. So for the 5,000 units, 50,000 negative 50,000 plus open bracket 5,000 times 10 minus 7 close parenthesis times 3.791 close bracket is equal to positive 6 £8,865. So thus we have a description of the range and probabilities of the outcomes. Remember that it has been assumed that sales volume is the only factor whose value is not known with certainty. So, example 6.2 vastly overplays the situation both by assuming that there are only three possible outcomes for the sales volume and by assuming that there is only one possible outcome for each of the other factors. So let us, however, take one more small step towards reality. So, solution. This situation is rather more complicated in that there are now 9 possible outcomes. Each of the 3 possible sales volume outcomes could occur in conjunction with each of the 3 possible labor costs. So the outcomes might usefully be represented in the diagram seen in figure 6.1. For ease of reference, the 9 possible outcomes are labeled E to I inclusive. From if sale will occur if 4,500 units per sold and the labor cost is £5 per unit, as the probability of the first is 0.5 and of the second 0.2, then the joint probability is the product of this, which is 0.10. That is 0.5 times 0.2. So note that the sum of the probabilities of all the 9 possibilities is 1. That is, one of them is certain to occur, though we do not know which one. So let's proceed to the example 6.3. So still staying with the data in example 6.1. So let us assume that not only that the sales volume has the same three possible outcomes, but that independent of sales volume, the cost of labor will be £3 per unit or 0.1 probable, £4 per unit or 0.7 probable, £5 per unit or 0.2 probable. So what are the possible outcomes and how likely is each one? So in this next slide, this shows the 9 possible outcomes A to I that could result from this project. So each one likelihood of occurrence is found by multiplying the probability of the relevant outcomes for sales volume with its counterpart for labor cost. So this is the NPV of each possibility R. So in the next slide, listing this in order of size we get. So there are possible outcomes, the NPV and the probability. So note that given the data, one of the above 9 outcomes must occur and only one can occur. As we have seen, a very modest attempt at reality causes complication. We can well imagine the possible number of possible outcomes were we to explore a more realistic sets of probabilities for each of the input factors, even with our simple example. So that's it for my part, and let's proceed to the next reporter. Thank you and God bless.